Let us discuss the concept of resonance. Now, resonance is when you can draw more than one valid Lewis dot structure for a molecule. Now, this differs slightly from isomers in that resonance structures essentially are the same structure. There just appears to be a slight movement of bonds. So from our lab, we drew SO2 looking something like this. If I were to draw the resonance structure for SO2, it would simply be appear to be moving the double bond to the other side of the molecule. So it would look like this molecule. Now, essentially, both of those molecules are the same thing, and in reality, the real molecule is an average of the two, which is why generally we put that double-headed arrow in the middle of the two structures. So SO2 technically would be an average of the two structures that you see on the screen right now. Another example would be the CO3 minus 2 polyatomic ion. When that was drawn in lab, that should have had a double bond in the structure as in this first Lewis dot diagram. Now, technically, the real CO3 minus 2 structure is a combination of all three of the resonance structures that you're seeing here on the screen. So the first structure, the second structure that I'm drawing here, and then the third structure where the double bond is moved yet again. And we're drawing three of those structures because there's three possible places for that double bond to be, and we need to represent all of the possibilities. And then again, the double-headed arrow is usually the notation in between each of those structures. So there is a second example of a resonance. A third example would be the NO3 minus 1 molecule. Now that has three resonance structures, much like the CO3 minus 2. So there's the resonance structure that has the double bond going up from the nitrogen. There is the resonance structure where the double bond is going down and to the left of the nitrogen. And then finally there is the resonance structure where the double bond is to the right and to the side, and then you have the single bonds in the other two positions. So if we were to draw NO3 minus correctly, it would really be all of three of these structures, again the double-headed arrows in between, to indicate that this real structure is an average of the structures. Now, we haven't done this yet in any of our structures, but technically, if an ion is being drawn, it should be in these bracket-type things, and then the charge outside. So SO2, this first molecule, did not have a charge, but these last two, because they have a charge, they should be in brackets, and then the charge is outside. And this is true regardless of whether they're resonance structures or not. So I'm going to draw those correctly by putting the charges outside. So these are more than one valid Lewis dot structures for a molecule. These are resonance structures.